Okay, so the second big hormonal axis that we're going to talk about after the thyroid axis is the corticosteroid and adrenal axis. Obviously, this is going to involve the adrenal gland. And so the adrenal gland is composed of two portions. The medulla, which is the first one that we're going to talk about, was actually not part of the corticosteroid axis. The adrenal medulla is in the middle. Think medulla middle. And the medulla is both an endocrine gland and a ganglion of the sympathetic nervous system. It is made of modified nerve cells, modified postganglionic sympathetic neurons called chromaffin cells. And here we are, chromaffin cells. And if you'll recall from way back in last term, sympathetic postganglionic neurons are unmyelinated. They usually are fairly short. Remember, the ganglion is usually located very close to the target organ, and the postganglionic, other way around. They're usually fairly long. The sympathetic ganglion is usually located in the paravertebral region. That's actually an exception in this case. So the adrenal ganglia is splanchnic, and it is sort of a secondary ganglion that's located much closer to the target organ, and you have shorter sympathetic fibers that are going to be unmyelinated, and they're modified. They're what are called neuroendocrine cells, which means that instead of synapsing with another neuron and spitting out neurotransmitter at small levels that's going to activate the next nerve in the sequence or whatever, they're going to spit out neurotransmitter at a fairly high level, and that neurotransmitter is going to diffuse into blood vessels in a capillary bed located nearby. And once they diffuse into that capillary bed, get into the bloodstream, they become hormones. And the neurotransmitter used by the sympathetic nervous system, postganglionic neurons, those are adrenergic neurons, and it is adrenaline or epinephrine or norepinephrine that they are using. So when the adrenal medulla is stimulated, it's stimulated by the nervous system, and the neuroendocrine cells in there secrete adrenaline into a capillary bed. The capillary bed takes that away, and you get adrenaline pumping through your system. It's not just adrenaline. It's what are called catecholamines, which is a class of hormones or neurotransmitters that includes epinephrine and norepinephrine, and a trace of dopamine. Dopamine is a reward signaler, a pain suppressor, and is at least partially responsible for sort of the high that you get when the adrenaline high that you get. The effects of adrenaline has lots of targets within the body and within the brain. It is going to, it's going to basically activate all of your fight or flight response that isn't directly innervated by the sympathetic nervous system. So things like your liver, your heart's directly innervated. Your liver, your adipocytes, your parts of your kidneys, You're going to mobilize high-energy fuels. You're going to start making glucose in your liver. You're going to start releasing fatty acids from your fat cells. Liver cells are going to make new glucose through the process of gluconeogenesis, and they're going to release stored glucose in glycogenolysis. And you're going to inhibit insulin so that sugar stays in the blood. Interestingly, like, not all cells actually require insulin to take in sugar. Specifically, like, muscle cells don't require insulin to take in sugar. They do that all the time. Same with neurons, the brain. So if you tell all of the other cells, don't take up sugar by suppressing insulin, then you have more sugar for your muscles and brain to use. And in general, it will also support a fatty acid metabolism in the muscles, because muscles can use fatty acids. If you recall, brain cells, neurons in the brain, actually can only use glucose, and that glucose has to be pre-processed for them by the astrocytes. The adrenaline will increase blood pressure, heart rate, blood flow to muscles, pulmonary airflow, metabolic rate, everything like that. And it does all of this very, very, very quickly. There are other hormones that do all of these things. Adrenaline or epinephrine has very fast effects, and it also tails off pretty quickly. The outside of the adrenal gland is called the cortex. Cortex means the outside of something. And from an endocrine perspective, if we talk about the cortex, we're almost always talking about the adrenal cortex. In a neurological perspective, if we're talking about the cortex, we're usually talking about the cortex of the brain. But here in this chapter, whenever you see cortex, it's going to mean adrenal cortex. The adrenal cortex secretes steroid hormones. Corticosteroids, technically, because cortico means from the cortex, and steroids are a type of lipid-soluble hormone. And there are 3 layers of the cortex that secrete different hormones. The outermost layer, which is thin, is called the zona glomerulosa. It secretes mineralocorticoids. Mineral is basically salts. Salts, whether we're talking sodium salts, phosphate salts, potassium salts, iron salts, anything like that. Metals, minerals, are almost always going to be salts in your body. So this actually regulates your body's electrolyte balance, and your body uses its electrolytes to regulate its water balance. So this is going to regulate salt levels and water levels, and we'll get into talking about this more when we cover the renal system. The second layer down, the middle layer, is the zona fasciculata. It's thick. It's the thickest of the 3 layers. You have cells that are arranged in long fascicles separated by capillaries. This is where the majority of glucocorticoids is going to be secreted. Also some androgens. So you might guess corticoid means thing that's secreted from the cortex. Glucocorticoid, they're named for the first function that was discovered for them, and that was that they caused your body to make glucose or to release glucose. In fact, glucocorticoids have a myriad of different functions in the body, and we don't by any means know everything that they do. But they are considered your body's stress hormone, and specifically your long-term stress hormone, as opposed to like adrenaline, which is more short-term. Stress is anytime your body has its homeostasis disturbed. And glucocorticoids are going to give your body, put your body in a situation where it can resist stress. Hopefully avoiding it altogether, but also dealing with it once it's happened. So resisting stress is clearly going to take energy, lots of it. So one of the things that it does is it causes a lot of sugars to be released from your liver. It causes your fat cells to start burning fat and turning it into sugar and releasing those as well. It's also going to have some fairly significant effects on the brain, on the metabolism. It's going to shut down things like, well, depending upon how long term we're talking about, it's in the short term, it's going to suppress appetite, but chronic stress over long term will actually cause carb craving, because it's going to cause you to like crave those carbs because they're going to be the fastest source of energy for you to get up and go, and get, more energy for more output. Androgens, or sex hormones, are also secreted by the zona fasciculata. Androgens are specifically masculinizing hormones. That's what androgen means. They're almost all going to be steroids. They're all going to be similar to testosterone. And they're going to be secreted in both men and women. They're going to be secreted at higher levels in men, first off. And secondly, in women, they're often going to be altered by other tissues into estrogens, which is feminizing hormones. But females, most females at least, have a certain circulating level of androgens, just like males do. And some women have more and some women have less. And this can have some consequences that we might talk about later on. The zona reticularis, which is the innermost layer, also secretes glucocorticoids and sex steroids, including the precursor of testosterone. So to just put a little bit more detail on that, right? The zona glomerulosa secretes mineralocorticoids. The main mineralocorticoid is aldosterone. This is something that we're going to talk about more when we talk about the renal system. It's going to have a lot of effect there. Zona fasciculata secreting glucocorticoids. There are several different types of glucocorticoids. Cortisol is the most abundant. But cortisone and corticosterone are also important ones. If someone is on steroid medication, it's almost certain that they are on a glucocorticoid derivative, probably a cortisol derivative. The zona reticularis secretes some glucocorticoids, but secretes more androgens and sex hormones. Of course, one of them is this one here that I'm not going to try to pronounce, but I believe it's abbreviated DHPT. It's the precursor for testosterone. Then down here we have the adrenal medulla. The adrenal medulla, of course, secretes adrenaline and noradrenaline, or epinephrine and norepinephrine. Specifically, by the way, aldosterone retains water and retains salt. So this is a diagram of the corticosteroid or adrenal hormone axis, right? Starts in the hypothalamus, as these things do. The hypothalamus secretes CRH corticotropin-releasing hormone. The hypothalamus doesn't constantly secrete CRH. Its secretion of CRH is regulated by several things. One of the main ones is stress. Any stress that your body feels, and this can be physical stress or mental stress or emotional stress, all of those signals get sent to the hypothalamus and they upregulate the amount of CRH that is produced. In addition, the circadian rhythm affects this as well. You tend to secrete less stress hormones when you are asleep, more when you are awake. Hence, just simply the process of being sleep deprived will have a tendency to produce more and more and more CRH, chronically high levels of stress hormones. CRH travels through the hypophyseal portal system to the anterior pituitary. And in the anterior pituitary, they stimulate the secretion of ACTH, adrenocorticotropic hormone. Adrenocorticotropic hormone goes to the adrenal gland, where it causes the release of primarily glucocorticoids and some catecholamines, but primarily glucocorticoids. Aldosterone is released through a different pathway, and the secretion of androgens is actually going to be controlled by much more by feedback from the FSH and LH pathways, the gonadotropin pathways, although there is some crosstalk, and it's certainly true that if you are chronically stressed, you may end up with either high or low levels of testosterone, depending upon what else is going on. These glucocorticoids are going to have some effects. First off, as we always see in these axes, they're going to have negative feedback effects. So glucocorticoids are going to have a negative feedback effect on the hypothalamus, downregulating the secretion of CRH, and a negative feedback effect on the anterior pituitary, downregulating the secretion of ACTH. They're also going to go off to the rest of the body and have numerous effects in the rest of the body. Glucocorticoids in the short term actually upregulate your immune system, but in the long term, if you suffer from chronic stress or repeated acute stress, then your immune system actually becomes suppressed instead. It's going to go to the muscles, and it is going to cause them to upregulate their metabolism to burn more energy. In the liver, it's going to tell the liver to release glucose and to begin digesting proteins and releasing amino acids and to make new glucose. It's going to go to your fat cells and tell them to release fatty acids for energy. It's going to go to your heart, tell your heart to increase its heart rate and the strength of its contractions. And there are a number of things that can go wrong with the system. Some of them are simply behavioral, like if you are overstressed or if your brain has become prone to activating the hypothalamus on this pathway, as can happen in people with, say, panic disorder or PTSD, then basically this neuronal pathway has become oversensitized and you're secreting CRH at much higher levels in circumstances in which it's inappropriate. But If you're secreting constantly high CRH, what are the consequences of that? Well, you're going to have a suppressed immune system. That's got bad things associated with it. You're constantly going to be pumping out sugar from your liver. Chronic stress is one of the major risk factors for diabetes. It's going to elevate your blood sugar levels. It affects fat cells in some fairly complicated ways. At least initially telling them to mobilize fatty acids, and then also telling them to like scavenge energy and turn it into more fat, so that it will have more fat to free out there, and it suppresses insulin, right? That's one of the ways that insulin is going to lower your blood sugar levels. Glucocorticoids are going to raise your blood sugar levels, so they're going to suppress insulin. And they do this through a couple of ways. One is they just tell the liver to make less, or the pancreas to make less insulin. But another way that they do it is they tell all of these other cells to become less sensitive to insulin. So, that's another way that they can lead to type 2 diabetes, is that they sort of start the pathway for insulin insensitivity, which is the key feature of type 2 diabetes. Stress is very highly related to that. And of course, stress also very highly related to heart disease. It's going to increase your heart rate, which is going to put additional stress on your heart. Your heart's a pretty significantly nifty muscle, but it was not made to constantly be racing. And if you do that, it's eventually going to suffer from what's called ventricular hypertrophy, where your blood pressure goes up to the point that your ventricles start to permanently enlarge. And when they enlarge, that means that they need more oxygen, which means that they now have to constantly be pumping more oxygen just to feed themselves, and it becomes a vicious cycle. I should emphasize, like, lots of diseases in modern culture, like diabetes, heart disease, things like that, are very much linked to chronic stress and high glucocorticoid levels, but glucocorticoids are absolutely necessary to live. You have them for a reason. They're extremely important. Without them, if you were to, for instance, like, not be able to secrete glucocorticoids, you would be in real danger of being, like, say, I don't know, like you see your bus and it's pulling away from the bus station and you're down the road and you run to catch up with it and then boom, fall over dead, because your body just can't respond to that stress of, oh crap, I gotta get to the bus, by giving you more sugar and, elevating your muscles' ability to respond to it. And you try to deal with this stressful situation, and then your body just says, nope, can't do it, collapses. So glucocorticoids are, like, really important. Like, not having glucocorticoids kills you real quick. Having too many of them kills you. It just kills you a lot slower.